From the Voyager and the Enterprise of the Star Trek series, so far antimatter propulsion has only been a matter of fiction. But just how far away are we from actually utilizing these similar types of propulsion systems in real life? And what would that look like?
So let's start with why exactly antimatter propulsion would be the best thing ever.
Simply put, it would be the purest and most efficient form of propulsion in the known universe. Not only do antimatter collisions convert 100% of mass into energy, it is 1,000 times more powerful than nuclear fission and 300 times more powerful than nuclear fusion. With just 10 grams of antimatter fuel, we could send a manned spacecraft to Mars in a month, a trip that at best usually takes around 11 months. So what is antimatter?
Antimatter is composed of antiparticles, which are essentially mirror particles because they have the same mass and they appear the same physically, but have the opposite charge of their counterparts.
Antimatter is created when high-energy particles are smashed together or they go through beta decay. But antimatter itself is extremely rare because when antimatter comes into contact with matter, it annihilates itself completely and releases pure energy. It's this kind of reaction that allows for antimatter propulsion to exist.
So now that we know what antimatter is, how would this be used to create a propulsion system?
Well, there are three main parts as to how this kind of propulsion system would work.
First, we have the magnetic storage rings, where antimatter would travel around the rings until they're ready to be used. Second, we have the feed system, which would send antimatter from the storage rings into the engine, where it would collide with matter. And finally, we have the magnetic rocket nozzle thruster, which is a magnetic nozzle that moves the energy created from the reaction through the thrusters. One example of how an antimatter spacecraft could look is the vacuum-to-antimatter rocket Interstellar Explorer system, also called the VARIES, proposed by the company Icarus Interstellar.
This rocket would use lasers to create an electric field that would create antimatter out of the vacuum of space itself and would entirely eliminate the need to create antimatter on Earth.
Right now, antimatter propulsion is very theoretical and still developing. The main things that are holding us back with antimatter propulsion are the availability of antimatter and its long-term storage. Also, it's extremely expensive to produce on Earth. Just 1 gram of antimatter costs $63 trillion. However, as we solve these problems over time and improve upon the designs of today, it will become increasingly likely that the spacecraft that your kids or grandkids will fly on will involve some sort of antimatter propulsion systems. So in conclusion, antimatter propulsion would be really, really awesome. A lot of scientists think that because of the increased speed, extreme efficiency, and energy potential, that antimatter could be the future of interstellar space travel.
There are so many new designs and technological advancements that could make this dream a reality, and I am so excited to see where the future will take us in spacecraft. Thank you so much for watching, and have a great day.